Many times in finding rare parts, it's easy to find one good part, but not a pair. Or you're trying to make many sets to sell as part of your small business. In this case, we have an original lens in good shape, which has been cleaned up and polished to a brilliant shine. The beauty of silicone mold making is that we can reproduce that shiny finish in the cast parts. You'll see in this video how a properly set up mold will produce many outstanding parts with almost no cleanup necessary. When setting up for a two-part silicone mold, we need to start with our splitter board to define where the mold splits in two halves. Luckily for us, the back of the lens is flat. If the lens has curvature or varied geometry on the back side, we can build it up using plastilina modeling clay. We prepare some scrap pieces of ABS plastic to build our mold box, which will contain the liquid silicone. As mentioned in our other mold making tutorials, many other materials can be used to do this, including Legos, cardboard, or metal. We also use our acrylic registration keys to provide sufficient alignment for the tool. These work very well and are available in our web store. It's time to lightly fasten the lens and registration keys to the splitter board using BJB's Instacure CA glue. A light spray of Instacure Accelerator is sprayed on the board to create an instant bond when the pieces are applied. Pay close attention to the amount of glue applied. We only need the tiniest drop to hold the lens and keys while being easy to remove later in the process. Before bonding the keys, we dry fit them to check the layout and to ensure some room between the lens and the mold box. Notice we made one key smaller to make alignment of the halves easier to see. We can mark their locations with a pencil. Once you're happy with the layout, glue down the registration keys. Remember, use very small dots of CA glue. Once the keys are placed, we can hot glue our mold box to the splitter board. Ensure a seal around the base to prevent silicone leakage. Clean the lens one more time before mixing and pouring the silicone. Note that we don't need to apply a mold release right now because silicone won't stick to these surfaces and we don't want to disturb the shiny surface. However, silicone will stick to itself, so we will need to mold release later in the mold making process. Cover the lens until we're ready to pour to prevent any dust. Remove the cover and pour our two-part mold silicone. You can find more information on how to properly weigh, mix, and remove air bubbles in BJB's intro mold making tutorials. Notice we're pouring a steady stream of silicone, taking care not to cause additional air bubbles. Continue filling the mold box to the top and then allow to cure. Once the silicone has cured a few hours later, we can remove the mold box. As mentioned in our other mold making videos, isopropyl alcohol helps loosen the hot glue holding things together. Carefully remove the ABS pieces. Wipe away any remaining alcohol. Begin to carefully pry up the silicone and registration keys from the splitter board. The keys and the lens should pop free fairly easily. It's best to leave the lens embedded in the silicone mold, being careful not to let it fall out or become dislodged. Carefully remove the registration keys from the silicone. Now it's time to add our acrylic vent posts and fill port. These will allow us to have pre-molded in vents and a place to insert our fill funnel. This is a much cleaner method than cutting in vents and fill ports after the mold is done. We lightly dip the point of the acrylic dowel into CA glue and place it onto the desired location. After a few seconds, we can let go and the vent post stays. As mentioned in our other tutorials, the strategy for placing vents in the fill port is to fill from the low point and vent to the high points. We'll also be tilting the mold to achieve a high and low point. Next, we need to apply mold release to the exposed silicone. In order not to disturb the high gloss finish on the back of the lens, we'll manually brush our ME301 release, which is basically a spray Vaseline. Using an acid brush, we reach into the deep registration grooves and carefully apply around the flange area. We also apply some release to the side exteriors in case silicone leaks out of the mold box. We make another mold box to contain the silicone as we pour the second mold half. Some scraps of wood and hot glue to hold it all together. To ensure a good seal around the sides and corners, we can brush our ME301 mold release or straight Vaseline for bigger gaps. It's now time to pour our second silicone mold half. Once again, we pour slowly and carefully to avoid creating unnecessary bubbles. Fill all the way to the top. Once the silicone is cured, we begin the process of removing the acrylic vents and fill port. A quick twist with pliers breaks loose the glue bond and they pull right out. Next, we remove the mold box to reveal the two silicone halves. Begin slowly separating the two mold halves, being careful of the molded in registration keys. And there we have it, a beautiful recreation of the shiny surface of the lens, ready to make more lenses. Time to cast the lens. Normally at this stage, we would spray an appropriate mold release onto the mold, but in a rare case like this, we will opt not to spray a mold release so our shiny surface is not compromised. You can expect a lowered mold life by doing this, but you save a lot of labor time by not needing to hand polish the cast lens piece later. We will strap the silicone mold to a rigid board to prevent any flex and to allow a way to angle the mold during casting. Don't over tighten the tape or you can distort the mold. Next, we'll insert our vent straws and pour funnel. We explain the benefits of the system in our intro mold tutorials, but in short, it's efficient and prevents a mess. We angle the mold for best filling performance and extraction of air in the mold. The material we'll use for casting the lens is BJB's WC783 water clear polyurethane. This system has proven itself for aftermarket automotive lenses due to its unique UV inhibitor additives and natural color stability over other casting resins. It is also a very strong, impact-resistant plastic when cured. Before we mix up our clear casting urethane, we need to consider our tinting options. A small test is performed to determine the loading of translucent dye to achieve the desired color. PSTF dyes are different than BJB standard pigments in that they allow light to pass through the urethane. You can find links in the video description or call BJB for more info. Time to mix our water clear polyurethane. We start by adding 45 drops of red tint to the pre-measured out B side and stir in. Then we add the A side. We're mixing up 100 grams to make sure we have enough material for the first cast, and we can dial back as necessary. The A and B mixture is stirred thoroughly for about 45 seconds. We will then place it in our vacuum chamber to extract the air bubbles mixed in. We'll discuss vacuum versus pressure casting later. After removing the degassed material from the vacuum chamber, we carefully pour it into our funnel, trying not to induce any unwanted air bubbles. The tall funnel will force the material through the mold thanks to gravity. A light tapping on the mold can assist in dislodging minor air bubbles inside the mold as the material moves through the cavity. After an overnight cure, we begin to demold our lens. You can accelerate the cure using moderate heat on the mold, or you can choose a faster work time version of our water clears. Contact BJB for more info. After the vents and pour funnel are removed, carefully pry the mold halves apart to reveal our beautiful lens. Notice the level of gloss recreated from our silicone mold and lack of air bubbles from building a properly set up silicone tool. And this was accomplished with no pressure tank. Now back to the topic of vacuum versus pressure as we mix our WC783 without vacuum degassing it. It's good to understand why you might want to use vacuum degassing in the casting process versus just using pressure. Vacuum physically removes air bubbles. Pressure simply squeezes the bubbles down to a less visible state, but technically doesn't eliminate the air. On rigid materials, the bubbles don't come back. On flexible materials like silicone and urethane rubber, the bubble can actually rebound back, causing deformities in your molds or parts. If you vacuum degas the material, pressure casting is used as an insurance policy to catch any incidental air bubbles produced as the material flows through the mold, or pressure can help force material into extremely fine detail or small air pockets in the mold geometry that can trap air. Pressure alone doesn't always get 100% of the air bubbles as seen in our face casting, but on some castings you might get away with it. Either way, it's good to know how and when to use both techniques. We hope you've enjoyed watching this tutorial.